Okay, good stuff. Hi, everybody. My name is Josh Long. I'm just sad we're not there together in person. I got to tell you, that's a bit of a bummer. I would have thought by the end of 2021, almost 2 years hence, that we would be congregating in person for these kinds of things. But it fills me with hope to know that at least we have the technology to stay connected virtually. So that's cool. So thank you very much for choosing to be here. It means all the more that you're here virtually, because again, you could go to the loo, you could go to the kitchen, you could go do all sorts of other things instead of hanging out here. And I appreciate that you chose to do that despite that. And especially after hours, right? Again, it's not like it's the middle of your workday. It's not like you have nothing else to do. No, you're here. And so again, it's doubly appreciated. I really, really am grateful for that. My name is Josh Long. I work on the Spring team. I'm a Kotlin Google developer expert, a Java champion, and of course, a Spring developer advocate. And most importantly, I'm at your service. So should you have comments, questions, feedback, whatever, don't hesitate to find me. I'm on the Twitters, I've got LinkedIn, I've got email, I've got all sorts of, I'm way too connected. Not particularly good at any of it, but I'm very connected. So find me there if you like. As was just well explained, I have a podcast, I have a YouTube channel, I stream, although it's been a bit crap recently because I've been doing CSS, which is not great. And then a blog. So all that stuff, find that there. And now let's talk about Kotlin, my friends. I've been using Kotlin a lot, but I gotta tell you, I wasn't initially, so sure about it. Like I didn't know what to expect when I first got into the language. I thought, well, why would I want to use it if it's just Java ++, right? If it's just another better Java, then where's the soul? What's the character about it? Why do people use it instead of just keeping staying put with Java? And that was like 2015, and I wasn't really all that sure about what would become of this language. And then I kind of realized a couple of things. Maybe it's 2014, then 2015, I kind of had this sort of aha moment where I started to appreciate the possibilities here, right? I started using this code and I started writing with it. And I realized that there's two big things that I love about Kotlin. Two things. Sorry about that. You wouldn't believe it, but I'm actually 12 floors up. So if you hear construction noise, that's astonishing. Anyway, I had two epiphanies, two things that kind of dawned on me that were kind of obvious in retrospect, but they weren't quite as clear as they could have been at the time for me. The language is useful for two big reasons. One is the team that work on it are pragmatic, right? It's a pragmatic language, certainly, but that's informed by the sort of ethic of the team that designs it and builds it and develops it and advocates for it, right? It is very much a pragmatic ecosystem, and it comes from the top, right? You can tell how good a language is going to be or not be. You can tell how good a language is going to be or not be based on the sort of the way that the team that works on it comports themselves, right? And I've just found them to be lovely, just absolutely amazing. They want this to be a pragmatic language. They've worked very hard to make this language pragmatic for people, and that's super important when you talk to a team. When you look at a team working in a language, some languages have very strong opinions about things, and that's where I was a little confused. Kotlin didn't seem to have a very strong opinion, right? And I thought, well, it means it doesn't stand for anything, right? But then I thought, well, Java doesn't really stand for anything today. I mean, certainly at the time, it stood for garbage collection. Like that's not a thing you need to stand for anymore, but it used to be. So it's just a very pragmatic language, and the team built this to be pragmatic. And the Spring team, we on the Spring team have worked with the Kotlin team in earnest for 5 years on since, and they've just been amazing, right? We can talk to them and say, okay, look, we want this to work. We want this to be a really great choice for people building applications on the server side with Spring. But there are these use cases that aren't well served just yet. What can we do? And the amount of collaboration, the amount of feedback we get, the amount of willingness to help and change and do whatever is required to make it the best option for people building Spring applications it's just astonishing. We've been able to work with them and have an idea, iterate on it, get it into the language, and then released within months. Try doing that with Java or even C#. It's just not as easy to do. with other language communities. Now, does that mean that Kotlin is compromised on backwards compatibility? Well, of course not, right? It's actually remarkably stable given the nature of the language. And that's the second thing I love about the language, which is that it's very elegant, right? It is Java++ in a lot of ways. I mean, there's in recent years, we've gotten coroutines, but it's not like before that. It wasn't like there was a single thing you could do in Kotlin that you really couldn't do in Java or something else. It's just that it's more rationalized. It's all clean, you know, and actually that matters. Day by day, inch by inch, you know, you start to appreciate the things that you don't have to notice, you know. The consistency is nice. And this is why I really start to like Kotlin. This is where I think it has become a better Java, is because it's just Java without all the sort of incongruent little features that were added and, you know, had to be tacked on. You know, languages have opinions, right? They have opinions by the things that they support and don't support. So they don't have to explicitly have a syntax, but the lack of that syntax or the lack of that thing is an opinion. And a lot of times languages can support certain design patterns, right? A design pattern is obviously a recognized solution for a software design problem. If the pattern is inelegant or makes things worse, they're called anti-patterns, or PHP for short. Now, this has meant that the choice that you have in language actually dictates what is possible. And I always kind of thought it was kind of weird that Kotlin, you know, didn't really introduce us to any new patterns. And so that's why I was hesitant. And then I kind of got into it, and yeah, it's just wonderful. It's just a very clean, nice, consistent language. And because it's so pragmatic, you know, you can see that Kotlin, the JetBrains team, have been working very hard to bring Kotlin to every platform, to every environment, to every context. So if you want to build mobile applications on Android, of course, it's the best and only choice really in 2021 to do. If you want to build native applications, if you want to have a better Rust or a better Go, you can do that with Kotlin native. If you want to build JavaScript, you can have a better TypeScript with Kotlin.js. If you want to do WebAssembly, if you want to do all sorts of things, you know, beyond just server-side JVM applications, it's got your back. And I just think that's kind of interesting, right? It's a weird play. It's not write once, run anywhere. It's one syntax, and then that takes you to different contexts. And obviously the contexts are different, and the APIs are different, and the ecosystems are different, and the constraints are different. But the fact that you can take your skills and just open up the door, it's not like you're going to make a lot of progress without learning the ecosystem. But the fact that it opens up the door for you is, again, remarkable, right? It's just a very consistent approach to getting started with things, and it's a very consistent language, and it's just become one of my favorites. So when Hadi Harari in 2016 invited me to come speak at the first Kotlin conf there in San Francisco, I was super excited. That was going to be in 2017. He invited me in 2016, and I said, great, I'd love to be there. It sounds like it'll be a lot of fun. Just me and a few of my fellow Kotlin enthusiasts. I live here in sunny San Francisco, but at the time I was on the plains. You know, I was anywhere but here. I was a nomad. So when he invited me to come back to San Francisco, I thought, oh, that's fantastic. I get to sleep in my own bed for you know, whatever. I was just super excited. I was just super excited to get home, and I thought worst case, I get to hang out with some fellow Kotlin enthusiasts, and we get to have a beer or something, whatever it is I was planning on us doing. I don't know. I have no idea. But yeah, it turned out it wasn't just a little get together. This event with almost no marketing, with almost no, you know, sort of energy around it. I didn't feel the energy going into it. That event had 1,500 people, you know, first one, and it was just 1,500 people. And it turned out that was all because of the Android sort of announcement. Do you all remember that? In 2017, Google came out and said, we support, not endorse, but we support Kotlin on Android, which to me is just, you know, it's fine. It's just another example of them being pragmatic, right? And then that changed the energy. That was Google I/O. And then, of course, here comes Kotlin Conf, and you could just see in the energy. You could see in the crowd, there's this huge crowd. A lot of them were there because of Spring, because there was service. We had been supporting Kotlin on the server side for more than a year, even on the Spring initializer by that point. But there's this huge community of Android developers. So my first question for all of y'all is, how many of you are doing server-side Kotlin versus, like, you know, mobile or some other context? I'm just curious. Who's doing server-side? I don't know how you can raise your hand in this thing. Maybe somebody could figure out a poll. I don't know. We'll get to it later. I always just wonder. That breakdown is just super interesting. There's 2. Okay. I see people using their hand wavy thingy. That's the technical term. 3, 4, 5. Okay. Now we're cooking. I'm going to assume Russ is in there. So I'm going to call that a nice even 6. Okay. Anyway, good stuff. So there's a fair amount of you, right? But it's just, to me, it's just very interesting that we've got this amazing community, and we have to, it doesn't, it's the language. It's not a particular context or application of that language. So anyway, from the Spring perspective, we wanted to support Kotlin. We wanted to make it a really nice fit for the language. So we built, for the ecosystem, for the framework. So we built support into the Spring initializer. That starts at spring.io. And that at the time was just, you can use the Kotlin syntax to write code against the Spring APIs, the Java APIs that were in jars that were just written for Java developers. There was no particular Kotlin integration. But in 2017, we released Spring Framework 5, which had Kotlin code in the core Spring Framework. One of the beautiful things about Kotlin is that you can easily extend existing APIs through the use of something called an extension function. These extension functions, as you all know, are a great way to paint some Kotlin-esque APIs into an otherwise Java API. So we were able to add Kotlin code in Spring Framework core. I don't know if you know much about Spring, but if you don't, Spring has been around since 2002 in some form or another. And in fact, a lot of the code that was written then is still there. It's backwards compatible. We do an incredible job of backwards compatibility. So the fact that there are now Kotlin code in the core Spring framework, it's not a separate jar. It's in the same jar you get when you use Spring for Java or for Groovy or for whatever else. It's not like we have a Kotlin module. No, no, no. It's in the core Spring code base. I think that's just insane. It's wonderful, but it shows you the extent to which we are committed to Kotlin. You know, we're once it's in, it's super hard to get rid of it because we have a huge community with millions and millions of users. And if we surface something as part of a public API, it's there. So we did this because we think Kotlin's a really nice language, and it kind of snowballed from there. The entire Spring team voluntarily sort of embraced Kotlin at that point, right? So on the Spring team, we're a large team. We have, you can go to spring.io/team. You can see our ranks, but basically, sometimes we have a theme or a thing that we care about, something that we're gonna pursue to make a feature or an idea more consistent across all the different portfolio projects. That's one thing, certainly. But this wasn't that. There was no like meeting. We all need to support Kotlin. There was none of that. It was just each project on their own, at their own leisure, at their own discretion, just said, well, this Kotlin thing looks pretty nice. I'll support it if I can. And we've just built different APIs. And so there's support throughout a good many different Spring portfolio projects for Kotlin. And it was just sort of organic. And it really came out nicely. And that it shows you that the team likes Kotlin as well. It wasn't one of those things where it's just like, oh, well, we should do this, but I guess we have to do this. Like it wasn't like that. It was just a really nice experience for us. So today, my friends, we're going to take a look at some of that. I like to talk about Kotlin in terms of its use in existing contexts, its use in new contexts, and so we're going to do that. We're going to look at basics here. We're going to look at existing, or let's say classic. There you go, classic. That's a more appropriate euphemism. Then we're going to use Kotlin. That's the language here. That's the important bit. That's the only thing that really matters that you've specified here. Normally, when if I give a presentation and I'm talking to people about Java, I would chide them that they need to be using Java 17. It's the only appropriate version of the JVM to be using today. And that is 90% true for you as well. If you're using anything on the JVM, it's inappropriate in all contexts to use 11 or 8. I don't see why you would, because it's less performant and less secure, less robust, less syntax rich, but you don't care about the syntax. I always have to remember that part, right? If you're using Kotlin, you've already got Java 25. So what do you care about Java 17, right? So you should be using the latest and greatest JRE to run your code, obviously, but one would forgive you if you don't actually care about the syntax. Okay, so let's see, what else? We want to build an application. We're going to build just a stock standard, trivial, typical application, something you've seen before, no doubt, a million times, something that uses JDBC. So we use H2, which is an in-memory embedded SQL data store. And because it's an in-memory embedded SQL data store, it's going to lose all of your data every time it restarts. Okay, so don't use it for anything production unless you want to set up the persistence. We're going to use JDBC, which is the Java Database Connectivity abstraction, because I make terrible life choices. So JDBC, and then we're going to use the Spring Web support. Okay. Now these are just some of the things we can use. We're gonna add one more thing a little bit further on here. So CD classic. Oh, what a language. What a nice language. I have code. Like if I was doing this presentation for a general sort of audience that wasn't, whoa, hey, I like how they give you ads when you start up the application. Repair IDE. Did you, wow, that's pretty cool. Did you see this? This is new to me. I haven't launched my IDE in, you know, gosh, 9-10 hours. So
I was gonna say that's fresh out today, I think, Josh. So
yeah,
bang up today.
Wow, Christmas come early. Kotlin compiler, the compiler bundled to Kotlin plugin is older than external compiler used for building modules. It's older. Oh, okay, well, you know, kind of have to. I'm sorry, but just what are you doing? You have the latest version of the plugin. Well, I think you should talk to each other, people. One thing just told me I don't. The other one just said you do. Okay, whatever. Yeah, that's new. That's a new feature. Christmas has arrived early for me. There's a repair IDE. That's, you know, I got to give it to the JetBrains folks. They aren't, they don't ignore their own issues, you know? Like, do you know there's a power saving mode on this thing? Which is to say, it wastes a lot of power by default. So if you'd like it to just temporarily not do that, you can click this button, apparently. And also there's now a repair mode. So if it breaks, because your IDE should break apparently, then that's there, which is great. At least they come by it honestly. That's cool. Yeah, good stuff. So anyway, that's the other thing I love about the Kotlin team. There used to be a very good experience for Kotlin in Eclipse, and the Kotlin team was actually the ones developing it, right? So which you got to give them a lot of credit. You got JetBrains actually wrote and helped maintain the plugin for Eclipse for Kotlin, because they really wanted it to be something that everybody could use as opposed to just the JetBrains IntelliJ folks. These days, of course, your best experience for Kotlin is obviously going to be IntelliJ or Android Studio or something like that. Okay, so we have our application. It's first of all, it's just a small font. I'm going to make that bigger here, friends. 22. Apply. Okay, I hope that's okay. If it's not, let me know. I'll make it even larger. I can't see the messages in the chat, so somebody just pipe up and I'll change it. So what I want to do is I want to build an application that persists data, right? Very trivial use case here. So I'm going to create a service, and we're going to create a function, which is a member function, not a method. You could call it that. People know, of course, but it's a function. We're going to say find all, okay? And I'm going to return a collection of a customer. Now, what's a customer? Well, I could, of course, build a Java-like class, private, val ID int equals blah, blah, blah. I can do that. But obviously, my dear friends, that it's much cleaner to use data classes. So I'll say val ID int val name string. Okay, there's my basic type. So I've got a service interface, and I want to create an implementation of that using JDBC. So I'll say class JDBC customer service. And already right off the bat, you can see we're just right into the right in the thick of it, and we haven't even done much to get there. We don't have to think about much, and that's because when you go to the Spring Initializer, it creates a new project for you that has everything you need to be able to use Kotlin. First things first, when you look at the build, you can see it's got support for the Kotlin Reflect and JDK8 standard lib, so it's compatible with everything everything since Java 8, right? So it doesn't mean you should use Java 8, quite the contrary. And we also set up the Kotlin Maven plugin for you. So this isn't here by default, obviously. Normally, when you create a new project, it just has this. So it's all done. If you're going to use Spring Boot just to bootstrap your Kotlin projects, that might be a good start. I mean, it actually just makes it very clean to get started. The more natural sort of use case might be to use Kotlin and Gradle, right? Obviously, I should have mentioned that. So if you do that, it'll create a settings and build that Gradle.kts, and it'll give you a Kotlin syntax Gradle build, right? Which is also very convenient. I'm just old school, and I want my code to be useful for 80% of the people that look at it. So I use Maven, but it's not a hill on which I care to die. Just use whatever you like, right? Okay, so I've already got a Kotlin build. In Spring, I want, you have this idea of dependency injection. Spring is a container for wiring up your objects and providing and helping you in the process of exposing your business logic. In order for that to happen, Spring needs to know how your objects are wired together. This is the process of dependency injection, the idea that you provide definitions of objects and something else consumes those constructed, defined instances, and they don't have to be aware of where that instance comes from, right? So they can write code in terms of their dependencies instead of the logic that's associated with how to get that dependency. So, for example, I can inject here a pointer to my JDBC template. Okay. Now the JDBC template is a type that's been in Spring since God was a boy or a girl or whatever the expression is these days. The JDBC template is a very convenient way to talk to the JDBC API. Okay, it's been around forever. Look at this. Where's my source code? Come on, right now. Go, go, go. There we go. May 3, 2001, right? It's just been around forever. It's why a lot of us started using Spring. I started using Spring because I wanted to bring in the JDBC template into my struts code, right? I wanted to be able to use that for my service tier, and I just wanted the library. I couldn't justify switching the application to Spring MVC. We couldn't even use the dependency injection because we just didn't have all that much to do with it yet. But the JDBC template was sort of like the Trojan horse, Once it's on the class path, you've already got Spring, you might as well start using Spring's dependency injection. So I love the JDBC template. It's a great way to talk to the JDBC API, which of course is, robust, if not the most elegant thing. And so it's there. It's been there forever. Keep that in mind, okay? We're talking about something that is 20 years old now, at least, right? May 3, 2001. We're now past May 3, 2021. It's a long time, okay? So we're going to build a type. We're going to annotate it as @service. This tells Spring that this type is to be made available. It's a bean. It's a Java object. You can tell because it has this marker annotation, which is, we call these stereotype annotations. This stereotype annotation is in turn meta annotated with @component. @component is the core Spring marker. All stereotype annotations are either @component or they are themselves are annotated with @component. So @service, @controller, @repository, etc. They're all transitively also @components. So I'm telling Spring this thing is a service and it's available for injection. It's the stereotype in the UML sense is that it's a service. The role is as a service. So I want to now create a service that reads the data from the SQL database. Well, obviously I can just return the data. So I can say this.jdbc template.query, select all from customers, okay? And this method takes a string and a row mapper, okay? So I'm gonna say row mapper, and let's do it the hard way first. I'm gonna use the row mapper customer, like so, and it takes a result set and an index, and I'll just return a customer object, all right? So the result set, I'll say, give me the integer ID rs.getString name, all right? So I'm just returning the results. Now, a couple things. Obviously, this can be cleaner. This whole thing right here can be a lot better, a lot more Kotlin-esque, right? So good. We can use an expression. That's nice. That's a big step up. Get rid of the return keyword and the curly brackets. This can be a lambda, right? So Kotlin has support for SAM interfaces, single abstract method interfaces, and those can be lambdas just like in Java 8. So I can get rid of this, remove that. Okay, now we've got a lambda. And in Kotlin, of course, if you have a lambda as a parameter and it's the last parameter or the only parameter, then it can live outside of the function parentheses, the invocation parentheses, kind of like a block in Ruby. So already you're kind of better off. This is not used, so I can rename it to that. So already you can see writing Spring code, it's nice, even if you don't have anything in particular for Spring. But what if I wanted to create another function here, right? Find by ID, ID int, and I'll just return a customer like so. And this may not exist, this customer, so I'm going to make it nullable. Okay, now I've got a new use case, right? I want to be able to say, return all the customers that have a certain ID. Okay, so copy and paste, select all from customers where ID equals question mark. Now the question then is, where does that question mark, well, what does that mean? That means it's a parameter that I need to pass in. So let's look at the signature here. The signature says it's one of these, right? SQL string args, and then the row mapper, or SQL string row mapper and then args. So row mapper, you can take this row mapper again, row mapper, customer, paste, and then we paste in the arguments. So it'll be just the ID. All right. Okay, so that's going to return a single result, and I want to get a object. Okay, there we go. So that looks like it'll work. So what do I get? I have a query for object. It's going to return a value, and I can use it. But the problem is that this is kind of ugly. Look at this. I've got a row mapper, and I've got the arguments at the end. So I've got the lambda right in the middle, right smack dab in the middle of my my function invocations, my member function invocations. So I want to clean this up. Obviously, we can do the same process, remove that, but we still have this lambda. Now, what in the Java world, variadic array arguments need to be the last argument in the invocation. So they go at the end. So this kind of makes sense because this is a variadic array of parameters that get passed in. So it could be like, whatever, right? The Java compiler requires that ability happens at the end. But in Kotlin, this is quite hideous. So what I want is to clean this up in such a way that I can actually have, I can have my parameters and I can have my lambda hanging off the side like a block. And so we have extension functions, right? So here's that, and there's this. See that? It's going to prompt me for an extension function. I bring that in, and now I get the same, I get that same great Kotlin taste, but without having to rebuild the library. This is an extension function, one of many in the Spring ecosystem. This one extends JDBC template or the core interface called JDBC operations. And you'll find that we do this a lot. A lot of times it's just a simple matter of taking an existing API that's been there for 20 years, which works just fine, and just reworking the parameters a little bit or adapting it in some ways that it is more idiomatic for Kotlin users. So that's the first thing I'd like to I hope we can dwell on for a second, is that we've done a lot of that. We've done a lot of like, how would this work idiomatically for a Kotlin user? So as to make it more accessible. So let's see, we've already got our interface, we've got our implementation. Let's actually use it. So create another Spring Bean here, class customer runner, okay, application runner. Alrighty, good. And what I want to do is I want to inject the JDBC's the customer service. So I'll say CS customer service, and I'll say return, not return. I'll say this.cs dot private val. This.cs dot find all dot for each print line it. All right, good. So there's this very, very basic bean. It's just going to run when the application runs, and we need to have some data, of course. So I'll go here and I'll bootstrap my in-memory embedded SQL data store with a schema. Create table customer ID serial primary key name varchar 255 not null. All right, good. And then we need some sample data as well. So data.sql insert into customer name values. People on the Spring team. All right, so I'm on the Spring team. Lucky me. Yushin, Madura, Olga, Violetta, Marcin, Stefan. All right, and who else? Who else is on the Spring team? Oh, the good Dr. Sire, of course. There we are. The great, the good. One of my all-time favorite doctors, along with Doctors Who, Strange, Fauci, etc. Right? Lots of great doctors out there. So people on the Spring team, got some data, we got some SQL. Let's run this and see what we get. Okay, got something. Not what we wanted, but we did get something. Table customers, not found, customer. Thank you, runtime. So you can see the problem here. I've got this, stringly typed code here. Okay, why is it running it as a Kotlin application? Whenever that happens, you want to ask it to run it as a Spring Boot application. Their cycle time is better. Goody. Okay, so there's my application. There's my data. It's worked. Congratulations. Everything is fine. Actually, I got a web server here. I brought in a web server. I don't know why I have a web server though. I don't actually need the web server. So let's just remove all that. Maven, reload the project, close this. Okay, there we go. So there's my data. Good stuff, right? We have data in the database. We're able to talk to it. It's fine, right? This is an API that it has a nice, clean Kotlin wrapper around it. And again, it works just fine. I'm happy with that. Now, already you've got something you can do some interesting things with. This is a regular, typical Spring application. You can take this application and use Spring Native. So I don't have, there you go. I didn't add it, but this is Spring Native. Spring, whoop, not Maven. Okay. So let me copy and paste this. Actually, let's try it. I haven't done this in the Kotlin world since they did the new 0.11 release, but you know, hashtag YOLO, what's the worst that could happen, right? So I'm going to add Spring Native to my build. Here's a native plugin and the Spring Boot Maven plugin. Does it still say it's still got the Kotlin bits? Good. So let's go ahead and rebuild this. I'm going to build it on another machine so it doesn't take all my RAM. Okay, so CD drive live, CD classic, cat pom.xml grep native. Yeah, good. All right, so what I'm going to do is I'm going to build this application. It's a traditional, just regular, you know, Kotlin application. You can see it works just fine. Starts up, prints out the data, everything's okay. So let's see. In the other machine, I want to run Maven p native clean package. Beg your pardon. There's some really aggressive road noise there. Okay. I don't know if this is going to work actually. I know it works in Java. Can't imagine why it wouldn't work in the Kotlin world, but hashtag YOLO. So let's find out. We just released Spring Native 0.11 like last week. So what I'm doing is I'm compiling my application into a GraalVM application. GraalVM is a just-in-time compiler that was created to replace the hotspot just-in-time compiler in the JDK, right? It's a just-in-time compiler that was written in Java. So it's a Java just-in-time compiler written in Java. It's a lot cleaner to look at and manage than the spaghetti C++ code that has become the eyesore that is the current hotspot code base. It's awesome. It's just really nice. And even in that capacity, it's worth using if you just want a better runtime for your JRE, for your Java code. But one of the things that the hotspot compiler does is it adaptively optimizes certain, frequently accessed code paths into native code at runtime. So it looks at certainly, successfully invoked or accessed code paths, turns them into native code so that the result is that the application, a poorly written Java application can actually be more performant at runtime than a well-written C or C++ application because of two things. One is this adaptive compilation to native code. And two is because of the whole world perspective that the just-in-time compiler has about the memory data flow in your application. Whereas a C program written in terms of resource initialization as acquisition can only see the local context in which memory lives, right? The creation and then the hopefully in the same scope destruction of that memory. So Java applications have a reputation for being fast, and it's fast enough, in fact, that some organizations like Google and Alibaba and others have famously done things to take advantage of that. They deploy a service into production and then they warm it up so as to see what it does, right? To get it to trip this hotspot compiler. Well, the question then is, why couldn't we just use that same hotspot compiler that turns our code into native code up front? Why do we have to warm it up? Why not just turn the whole thing into native code? And that's what the GraalVM native image builder does. It's an AOT. It's an AOT compiler. What it does is it adaptively, it proactively compiles everything into native architecture specific code. And this is done at compile time. It does an analysis of your code base and turns it into a binary that you can use in a particular architecture, and there's no JRE. So the result is very trimmed down. The problem is, of course, that it's done at compile time. Remember, Java and the JVM and Kotlin and all these other languages that sit atop the JVM are funny old languages. They're funny old runtimes. Java, for all of its warts and all that stuff, the Java platform, for all of its warts, while it may feel sometimes like C or C++ with its compiler and all that, it's actually really dynamic. It has a lot more fluidity, a lot more dynamic sort of behavior than people seem to expect. It's a lot more in common with something like Ruby or Perl or JavaScript or whatever in terms of runtime. And because, I mean, think about this, right? I can actually write the class. I can write a class inside of a Java string. Like I can write the syntax for a Java class file in a Java string. I can then compile that string at runtime. I can then take that compiled .class file on the disk, load it into the class loader. I can then, using reflection, create an instance of that class. I can then take that that class and create a proxy out of it, a JDK invocation handler proxy. If I want to, I can make that proxy implement serializable. If that's the case, then I can also persist that instance to disk and restore its bytes in some other JVM, all after the application is started up, right? It's basically eval. I can do eval, EVAL, in the JVM, on the JVM. That's incredible, right? That means that it's a very dynamic language. And the GraalVM compiler can't see any of that. And so what GraalVM tries to do is it looks at your code and it throws away all the stuff in your code that it thinks you're not going to need at runtime. Everything, your hopes, your dreams, your library, class paths, dependencies, everything goes away, chucks it out the window. So what you have to do is tell GraalVM, hey, no, I'm going to need that. Don't throw that away. And that's done through a mechanism called hints. Well, we created a project called Spring Native. Spring Native knows about all the different dynamic things your typical Java and Spring application is going to do. It feeds those hints to the GraalVM compiler for you. So, by the way, this took 3 minutes and 25 seconds. That's a long time. That's because I forgot to do this, right? I forgot to skip the tests. So when you compile a native application using Spring with hashtag -p native, what it does is it compiles the tests into native code, then runs those tests. Then it compiles the production code into native code and then gives you that. So it actually did 2 native image compilations. And again, each one takes a fair amount of time. Even without the tests, it's still about 1.5 minutes, maybe 1 minute and 25 seconds to do that compilation. And the reason is, as I said before, because it's not just compiling your .java source code files, it's also compiling all the .class files into native code after it's done the analysis to determine what all should remain in that code. So what do we have here? Classic, whoops, nope. There's my native application. 69 milliseconds, right? No, that's actually, okay. So there you go. There's your 0.082, 82 milliseconds, somewhere in there. It's less than 100 milliseconds to get an application that talks to a SQL, that actually has a SQL database embedded, and then it talks to it. A full SQL 99 embedded database that it then talks to. Okay, so you can do that, right? And this is, I like Kotlin native, but if you want server-side JVM code and you want it to run like native, well, now you can. This application, classic. This application is, I don't know, what is it? DUHS classic, 85 megs, and that's self-contained. That's a Mac specific binary, but I don't need to have Java installed. I don't need to have anything installed. That's everything. You can actually use the Spring Boot support for build packs. You can say Spring Boot build-image. And what that'll do is it'll build your native binary, your architecture specific binary in a Linux container that is a Docker image. And then it'll output a Docker container that you can then Docker tag and Docker publish or Docker push, to your container registry of choice, right? Be it GCR, Docker Hub, or VMware's Harbor, or whatever. That's pretty cool too. So now you've got a Linux binary, you've got a Linux native image that runs inside of a Linux Docker image that you can then use inside of your cluster, your Kubernetes cluster. So okay, that's certainly one option. But what I wanted to do was to kind of look at using APIs from the Kotlin ecosystem to make this just that much more elegant, right? Because one thing you notice, I fat fingered the name of the table there, and I could certainly have gotten into more trouble with these names, the field names and so on. What I want is to, first of all, centralize all the stringy bits, and then second of all, to take advantage of the types later on. And so I can use the JetBrains Exposed ORM. Okay, so I say dependency, and it's JetBrains Exposed Spring Boot Starter 0362. Yeah, there you go. So let's add this to the class path. Okay, and Exposed is very nice. I'm a big fan. They have a Spring Boot Starter because, again, very pragmatic. If you want to use this stuff, obviously Exposed only works in Kotlin. It's not going to be a great choice if you're using it from Java, but that's okay. And it's one of those things that takes full advantage of Kotlin, right? As opposed to just using existing APIs from Kotlin. So what I'm going to do is I'm going to now teach Exposed about my database, my table. And the way you do that is you provide an object that has configuration, right? Well, we're only going to use that object once, right? So it's not like I need to actually create many of them. So of course, in Kotlin, that idiom, that singleton idiom, is just to create a type of object, right? So customers is going to extend the table. And so, yeah, I'm providing I've got a string here, but I've got it in one place, right? That's the important bit. Now I'm going to describe the arrangement, the makeup of my table. So I'll say that the ID is an integer, it's got an ID, and it's going to be auto-incrementing. Great. I also want the name. The name is varchar name. It'll be 255, etc. Okay, so that's it. So yes, I've got strings there, but that's the extent of it. I've limited it to this. So now I want to create a ORM, exposed ORM implementation of that interface. So class exposed customer service. Okay. Implement members. Oops. Goody. Okay, so there's my implementation. Same as before. And here I just use this, I say select all dot map. And here I've got a result row, which is like a result set. And I want to map each record into a customer object. So I say it, and the index, obviously there's operator overloading here. The index is provided by the types, right? You can index into the individual rows via the attribute names in the table description. Okay, so ID and customers dot name. All right, that's not so bad. Let's try this again for the other one. This one's a little bit more involved, isn't it? So here we're going to say select. Let's see, select where, and this part I always forget. I need to build an expression. What do I do here? Is it like this? No. Let's see. Let me do a quick exposed ORM JetBrains select where. I always forget this part. Where users delete. Is it just dot where? So customers dot where? No. No, that's not it. Select and nope. That's not great. Oh, well, I'm not even using this, so we'll just leave that as not implemented. Not implemented. Oops. Oh, to do. There you go. Not done yet. All right, so there's this. Okay, so I've got my basic select all. Let's go ahead and run this again just to confirm that it's going to work. Actually, we know it's not going to work. And the reason is because Exposed expects to be run within the context of an ongoing transaction. So that transaction has to be started before you start using the exposed session. Well, Spring has this thing called the Platform Transaction Manager, right? The Platform Transaction Manager is a core abstraction that's, again, it's been around in Spring since forever, right? It says 2003, right? This interface has a very core basic contract. Give me a transaction if it's ongoing, or if it's not, start a new one, commit it or roll it back. Very simple. That abstraction has been adapted to work with a number of different interfaces. So JDBC, JPA, long time ago there was JDO and OJB support, Hibernate, JTA. I mean, all these different sort of contexts you can imagine. JMS, Neo4j, MongoDB, etc. All these different contexts where you expect to be able to manage transactions. There's an implementation of that interface, so you can write code that declaratively manages transactions in terms of that interface. Well, wouldn't it be nice if I could declaratively start and stop an exposed transaction? Well, it turns out, thanks to the auto configuration in the exposed starter, I can. And so all I need to do is to make sure that I tell Spring to automatically start that transaction, just like I would any other transaction, by using @transactional. This will in turn create an aspect, which in turn invokes or involves the platform transaction manager implementation at some point down the stream, right? Okay, so now let's run this. Consider defining a bean. Okay, maybe it's a cached thing. Huzzah. Okay, so there we go. There's our data. We got it back, but this time we're using exposed as opposed to just core JDBC. So okay, not a big deal, right? All we've done is we looked at some basic code that you could have written 20 years ago in Java, and you can see it's just that much better just for its use in Kotlin. And because Kotlin is, again, very pragmatic, we've made it very easy. They made it very easy for us to adapt existing APIs to make them more idiomatic, more natural. And if you keep going into the Kotlin ecosystem, you're going to find that there's a lot to love about it because it has this really rich sort of ecosystem full of libraries. And you shouldn't go into a language wanting only to hew to the stuff you already know. You want to embrace the sort of local paradigms, right? When in Kotlin do as the Kotlinians, Kotlin types, I don't know. When they do what they do. Okay, so that's one thing. The other really interesting application for me in Kotlin is in the creation of DSLs, and there are a good many DSLs in the Kotlin and Spring ecosystem. So let's say we wanted to do that, okay? DSLs, okay? Kotlin, and I'm going to create a reactive web application using Spring Cloud Gateway. Okay, so just some basic stuff here. What else? I want to create a simple service that returns some JSON data. So, okay, let's create this. This is going to be our client, okay? Generate, and I'm going to create a profile service as well, using Kotlin. We don't need this for that. So we'll just hit generate, and we'll go back up. UAO profiles.zip. So we're going to create a little service here just so we have something with which we can talk so that we can work with it. Oops. Am I in the wrong? I'm in the wrong one. UAO profiles.zip. Okay, hopefully I'm running on the right Mac. There you are. Okay, so profiles, this is just a simple application to serve up some data. Okay, so we're going to say @controller @response body class customer, profile REST controller. And I'm going to create a constructor here. And I'm going to store some data in memory just so we have something with which to work. So private val map or db equals current map integer. And we need a type here, data class profile val ID int val customer ID, whatever. Just a thing that can return data for us. Okay, so profile. Good. Okay, good. So db dot 0 equals profile. And actually, you know what? I don't need all this. We just need something, anything. There you go. 1, 2, 3. This is 2. Good. Okay, so there's our 3 records. Let's go ahead and start this up. There you go. Okay, so that's there. Now, let's use the DSL. So UAO DSLs .zip. And what I want to do is I want to build an application that talks to that SQL, to that HTTP endpoint that we created earlier. And I want to just take a look at ways that we can make our code a little bit more Kotlin-esque. Okay, so first things first, notice that when we get a brand new Spring Boot application using the Kotlin DSL, even the entry point into the application is a little different. This isn't your typical public static void main that you see in Java. Obviously, it's a standalone main function. In the main function, usually in the JVM world, in the Java world, you have something called Spring application.run, and then you put in the name of the main class, so that would be this, and then you have the args, right? And you have to expand it, right? So there you go. So yeah, that's what it would normally look like in Java, but we're not doing that. Actually, that would be there too, but we're not doing that, are we? We're actually using a function that has a pseudo reified generic. So one application, and it takes a reified type T, which is the name of the class. And because we can capture that generic type, basically we can do T.class because of the way that Kotlin kind of reifies this type for us. Because we can do that at runtime, because we can capture that, we don't have to specify it twice. We don't have to specify the generic type here in the function parameters. And so we can just pass in the arguments. Again, just right out of the gate. First thing you do when you create a new Kotlin application is you work in terms of the Kotlin language. So, okay, I've got that. Now I want to create an endpoint. Let's say I want to create an endpoint that supports cores, right? This is like an edge service. And so a great way to do that would be to use Spring Cloud Gateway, right? So Spring Cloud Gateway is a API gateway that allows you to talk to downstream APIs and to proxy them and to adapt them and to make them more palatable for clients that need to work around their particular quirks. Maybe you have an iPhone that has a different way of doing security versus your PlayStation or Xbox client or Android client or whatever. So we can use Spring Cloud Gateway. Okay, great. So let's do that. We'll say bean gateway, RLB, route locator builder, and you got to return a type of route locator. So that's the contract, right? Given an RLB, you return a route locator builder. And then when you build the routes, you have a route spec. And here, sorry, I'm gonna route. You get a route spec, And here I want to actually define a predicate so that I can describe how a request intended for this port 9999 gets routed to its downstream service. So I'm going to say, given a request going to /proxy, I want to send it onward to, let's say, our downstream profile service. Didn't I create that endpoint over here? Yeah, I did, right? There's some data there. I didn't create the actual endpoint, did I? Look at that. Okay, so profiles, fun profiles equals this.db.values, okay, and get mapping profiles CID, fun profile by ID, path variable CID int CID, okay? So I'm just returning the data as it's asked for. Okay, so I'm going to proxy that downstream service running on port 8080, and I want to get the profiles data, okay? But the problem is the request is going to arrive unadulterated using the proxy path, and if I forward it unadulterated to the profiles path, then I'll arrive at profiles/proxy, which doesn't exist, right? So I need to change the path rather than just augmenting it or adding to it. So I use a filter, okay? So here, fs.setPath equals profiles. I get rid of that. So the filters are where Spring Cloud Gateway has its power, okay? And there's all sorts of filters for retries and adding cores headers and, let's say add response header. Let's see, add response header, HTTP headers dot, access control allow origin. Voila. So now I've just added core support to that endpoint, and I don't have to change the downstream microservice. This is a very common pattern, right? Like an API adapter, API gateway, etc. All right, you can see that the IDE is not pleased with what I've just done here. First of all, even in the Kotlin language, even if I'm just using the Java API, I can do better. This can, of course, live outside the Lambda, okay? And as can this filter invocation. Okay, very good. So that's a lot better. But the thing of it is, this is still very much a Java API. And I told you earlier that we've done a lot to make the APIs more idiomatic, okay? And that's true for lots of different things. So before we get back to this, let's go take a look at this HTTP endpoint that I built. You can use the controller style definition if you like. That's certainly possible. But did you know that we also have support for a functional HTTP style, a functional reactive HTTP style? So I'm going to say profile routes. And normally what you do is you create a router function with a response value of type server response. But we actually, this router function, we actually have, support here for building the endpoints like this. You can say route, and then get. So profiles, given the profiles, and what I'm going to do is I'm going to move my sample data up here. Okay, good. Goodbye to that. Goodbye to this. Okay. So when a request comes in to / profiles, I need to produce a response. And so I will return, I'll say, I can just say DB, I can say server response dot body, dot OK dot body is DB dot values. And the value, the type that I'm sending back, well, it's just a profile, isn't it? So I need to specify the type here, profile class Java. Okay, there you go. So it's a collection of profiles. Actually, I can say body value. There you go. That's better. Okay, good. And what about the other one? I can say get profiles CID. Okay, and then return server response dot OK dot body value DB, and then the request is it variables, path variables, CID, val CID equals that. This is equal to a type of string. So I want to turn it into an integer, right? I can say int equals int dot integer dot parse int. Kind of a bespoke way to do it, but it works. So CID, very good. And again, I'm just returning a single value here. What's the issue? Oh, sometimes that error can be very confounding. See, that it's trying to tell me, hey, I'm expecting a value and you've just given me something that's nullable. So you've got a couple options. You can wrap it with a .NET call, or if you feel like yelling at it and you really just want to let your frustration out because it just seems like an obvious error, but you can't figure out why, just yell at it. The syntax appreciates it. Okay, good. So now I've got my simple rewritten functional reactive style, but notice I've got this nice DSL, right? This is all just very, very clean. There is a similar DSL, but it's not nearly so nice in the Java ecosystem, in the Java world, right? So now I don't have to have that controller. Okay, so let's restart that. Nope, wrong one, come on. Goody, so let's confirm all that's working. So 8080 profiles, goody, there you go, okay? So we got the results. Now let's go back to our DSL. So now I'm using the function, let's use the functional reactive DSL, or let's use the Kotlin DSL rather, for Spring Cloud Gateway in the same way that I was able to paint the HTTP endpoints with that nice fresh code of Kotlin DSLs. We can do that with Spring Cloud Gateway. So I say routes, okay, that goes in there, and take all that, we drop this, drop that. Notice that's an extension function. I create a route, and in the route, I define the predicate, the filters, and the downstream URI. Okay, so route here, good. So what do we got? We got the routes. I think I'm missing a parentheses. Keep it cleaner for a second. This is the nice thing about, oh, okay, yeah, sure. So I can make this an expression. Get those up there. Goody. Seems okay? That seems okay to me. And what about you? Are you okay? You seem, this could be down there. All right, good. That took a minute. See, this is the nice thing about bringing functional reactive programming to the JVM. Now we too can enjoy the fun of pattern matching around or parenthesis counting that our friends in the Lisp community has so long kept for themselves. So we got a very simple route, which has a path, which is the predicate that matches the incoming request. We want to add a filter, and we can just say set path equals profiles. All right, there we go. So that's the Spring Cloud Gateway DSL for Kotlin. Let's run this. Nope. I don't know why IntelliJ has forgotten how to be IntelliJ, but it's not great. Okay, so localhost 9999/proxy, and there we go. I'm proxying the data from the downstream service. It's complaining about Netty, which is not us. It's just some downstream thing. I don't quite understand why that issue is there, but wish it would go away. It's dumb. All right, so there's the proxy. Okay, it's proxying the downstream service. It's worked just fine. I've got a nice DSL, but even this problem, even this thing we're doing right here, I'm creating a bean using a bean provider method. Well, there's actually a functional way to do that. And that functional way is basically you can programmatically register beans in the application context. It's fine. You can do it from Java. I wouldn't recommend it. Actually, a couple things. First of all, you don't need to because, it's not like it's at scale, it adds a lot of difference, but for your particular beans, it's not going to make a huge difference. You should know that that native AOT support that I looked at before, that AOT Spring native support, that actually transpiles all your Java configuration classes with @bean methods into this functional configuration style. I wonder if that's still there. Can we see that? Did I already delete the code? CD classic, CD target, CD generated sources. Oh yeah, it's gone. Well, okay, let's see if we can do this. Maven skip tests. Clean package. No, I'm not doing the native. I just want the AOT stuff to kick in. See, processed 182 bean definitions. And, okay, there's that. So now go to the target, CD generated sources, CD Spring AOT, tree. Oh, I don't have tree. Seriously? That's got to be fixed right now. Okay, so find. There you go. See that? So if you look at these files, these classes, these were code generated for you. Cat. Voila. And what that's doing is it's using this functional reactive functional endpoint to programmatically register the same beans that were defined in auto configuration classes using @bean annotated methods, right? So we're doing this because this is actually a lot faster in the large than reflecting upon these @configuration and @bean annotated methods. So we're doing that for you when you're using Spring AOT. We do that translation for you. That's it. It's a nice way to write configuration in Kotlin. In Kotlin, it's very nice. So first things first, what we want to do is we want to get a pointer to the application context in which we can register our beans. So this run application, like I said, it actually takes a lambda. The second parameter is technically a lambda that's run in the scope of or in the context of the Spring application. So this, the pointer to this is Spring application. It's not my actual DSL's application.kt, okay? And this is a nice thing. You can actually create extension functions that are said to be, they have this pointer is some other type, right? Because they get applied in the context of that type. So I can say this dot initializers, add initializer, right? And what I want to do is I want to create an initializer that does functional registration of objects, so I can use this nice DSL. And the bean that I want to register here is this route locator, right? So I'm going to take this, but of course, in order to do that, I need a pointer to the route locator builder. So I can say, give me a pointer to the route locator builder. I'm going to inject that reference, so to speak. So there you go. I'm using the ref type. I don't have to specify the .class type token. I don't have to say .class because, again, reified generics. And actually, I can go a step further. I can just cut out the middle type there. So I can say, given this type, I want to create the routes, and here's the routes, and so on. So this is an example of rewriting code to use the functional DSL. I think it's a lot nicer than, in the functional world, in the Kotlin world. If you want to write things like this, you can. It's very convenient, and you can see we've got these DSLs. So I showed you DSLs for HTTP and for Spring Cloud Gateway. Now, let's say here on this side, I actually wanted to talk to that other downstream service, the profile service, right? I want to create another HTTP endpoint that just calls that endpoint directly, okay? So let's say I did that. I wanted to create a class, CRM, or let's say profile client, okay? And in order to create this class, I'm going to need a non-blocking web client, a reactive non-blocking scalable HTTP client. I'm going to inject that here. This is going to be a regular Spring Bean. I need to factory an instance of that web client. So I'll do that here. I'll say WCB web client.builder. I'm going to look that up. So val WCB equals ref. Okay. And I'll say WCB.build. So that's the type I'm returning. It's a, if I say val HTTP equals, then what this is a web client. I'm just going to return that here. So return HTTP, good stuff. And obviously I did that so you could see the type, but it's more suitable to just inline it. Okay, so I'm going to use that HTTP client here. And what I want to do is I want to call that downstream service. Remember that downstream service gives me the profile information and the profile by ID. So I want to get the profile by ID, let's say. So fun profile by ID, ID int, and it'll return a profile. That's the contract here. Now, what is a profile? Well, of course, I'm going to do something terrible, something that you should never, ever do, ever, not even when you're all by yourself at home and no one is looking. I'm going to copy and paste code. And I'm going to copy and paste this DTO, this transfer object, into my client code. And I'll say, okay, return this.http.get.uri, HTTP localhost 8080/profiles CID. And I'll just pass an ID, and the data that I expect to come back is a profile. So body to mono of type profile, val reactive profile. I've got like a completable future, right? This is something called a mono, okay? Let's inject that. Let's get that in the class path. Return reactive profile, okay? Now, the thing is, I could return, and it's very common in the Java ecosystem to do this, I could return a reactive type. I could say this is actually a reactive value of type profile, as opposed to, let's see, this is, well, you know what, that's fine. I could do that. I could just inline it like that, and that'd be fine. The thing is, when you're using these reactive types, you have to know about how to write data flow in terms of those reactive types, which again, you saw me do it. It's not so bad. It's like using the Java 8 Streams API, but it does take a minute for people to get used to. And in the Kotlin ecosystem, they have something that really, they can offer an alternative. The reason we're using these reactive types is because if we write code in terms of these reactive types, the runtime will know when we're doing something and when we're not, because we can say, hey, I'm asking for data. And then when we're not doing anything with data, when we're just sitting there waiting around, we can tell the runtime, hey, we're not doing anything. And this is very common. Whenever you do input and output, for example, you're probably going to sit there waiting for something. And so it's better not to sit there on a thread. It's better to do that in the background. And that's supported by things like asynchronous IO. So reactive types give us the ability to say, I want something asynchronously, but as soon as I've asked for it, I don't need the thread anymore. You can give it back to the runtime. So this gives us better resource efficiency. It allows us to scale to greater heights to handle more transactions at the same time. But like I said, you have to write code in terms of these reactive types. So Kotlin gives us an alternative. Kotlin gives us something called coroutines. And in coroutines, you can just write suspend functions. You can say, hey, this function is going to do something that's asynchronous. And I don't want you to wait for it, right? I want you to suspend while we're asking for that data. And in between the time when we've asked for the data and when it arrives, I want you to suspend the thread and put it back in the thread pool. So these reactive types are natural fits for coroutines. You can take any reactive type and turn it into a coroutine awaitable type by saying await single or await whatever. So now what I'm doing is I'm saying, let's see, return that. Okay. And what's the issue here? Get URI. Oh, right. Okay. I want this here. Profile. Okay. So what I'm doing is I'm saying, give me the HTTP, make the HTTP request, give me a reactive type, and then adapt that to a coroutine type, a suspendable type. And the result is that I'm writing this code that looks like it's just returning a profile, but behind the scenes, that might take an hour. Maybe the service is down. Maybe I've got like a timeout. Maybe it's actually a lot of data. Who knows? But the client thread that's making that request is not going to sit there waiting. And I've told the compiler that by use of this suspend function. Well, you need to have a web framework that knows about that suspend function. And we do, right? In the Spring world, we have a co-router. You saw me use the router earlier, right? There's also a coroutine router. So co-router, okay? So same idea as before. I'm going to look up the client. I'll say profile client equals ref profile client. Just being very explicit here. And then I can say profiles, ID. And we're basically writing the same code as before, but this time we're returning using profile. So say server response dot okay dot body value and await. Okay. So I'm not just returning a value, I'm returning a suspendable value. So I'm going to use client. I'll say client dot profile by ID. And just as before, I'll say, it dot path variable ID. And I'm going to turn that into an integer dot parse int, et voila. Okay. Let's see, profile. What's the issue here? Found profile. Okay, well, yeah. So again, make that happy. Okay. So basically it's the same code, except that we can use these profile, the coroutines. And the important part is that most of the code inside is the same. What's important is that you remember that at the outermost scope, somewhere in the framework level, ideally, there needs to be a coroutine context. That's what we're doing here. We're setting up a coroutine context so that within the reactive code, or within the web code rather, there's a coroutine context always present. So when you call a service or do anything else like that, it'll just automatically work. Now, when you're writing a Spring controller, an HTTP controller or an RSocket controller or a GraphQL controller or a WebSocket controller, when you're writing those controllers, you just have to add the suspend keyword. You don't have to, there's no separate annotations or anything like that, right? If you're not using the function reactive style, that's fine. You can just use regular controllers. Let's restart. Let's see what that gets us. Okay, so localhost 9999 profiles to, et voila. Okay, so we're calling the downstream web service from the edge service, from our gateway code, and we're doing it in terms of coroutines. And yes, there's some blocking in there, but we're not keeping that thread open. So we got now through the use of coroutines in Kotlin and the DSLs and APIs in Spring, we've got not only the most concise version of this code, it's hard to argue, it's inarguably as efficient as you're going to get, right? It's very clean, very small, very svelte. But it's also the most approachable code because all we're doing is we're dealing with profiles. We're dealing with types that we care about, right? So this is one of the nice benefits about, one of the benefits of Kotlin is that you get really concise code. That's also the best version of the code. This is the most efficient, most scalable, most performant version of the code. And because it's using reactive APIs, and reactive APIs in turn support operators like .retry and on error resume, because you've got that, you've also got the most robust version of the code, right? All right, my friends, we've looked at a few things here that really just please me about the Kotlin ecosystem. I appreciate that I've run a little longer than my original 50-minute allotment, but there's just so much stuff to talk about these days. I appreciate your time. I think we just looked at a few things here, just a few things that are just neat about the use of Kotlin in the Spring ecosystem. I'm happy to answer any questions, and as always, thanks for your time. And I hope you have a wonderful, safe, happy holidays if you celebrate, and a happy new year.